Welcome everyone to our fraction series, the JSCE aspect of it. Today we'll be starting up with multiplication and division of fractions. Unlike in addition and subtraction, we cancel out or reduce to lowest term in multiplication and division. Let's take some examples involving multiplication only. Simplify 1 over 2 times 6 over 7. Solution. Our problem, which is 1 over 2 times 6 over 7, sometimes we cancel out 2, we cancel out, divide 6, and we give you 3. So the result will be 3 over 7. Another example. Simplify 1 over 2 over 3 of 9 over 20. Of course, in the solution, of means multiplication. Next, we change mixed numbers to improper fraction. And our one whole number 2 over 3 of 9 over 20 will be equals to 5 over 3 times 9 over 20. Sometimes we cancel out. 3 we cancel out with 9, and you will be left with 3 there. 3 here, 1, 3 into 9 will give you 3. 5, you cancel out 1, and then when you divide 20, you give 4, and that the result will be 3 over 4. Another example. Find 7 over 9 of 6 over 3 over 7. The options are given. Solution. We change mixed number to improper fraction, knowing that of is multiplication. Our given problem, which is 7 over 9 of 6 whole number 3 over 7, will be equals to 7 over 9 times 45 over 7. Sometimes we cancel out and we left with 5 over 1. The result will be equals to 5 over 1. I hope you know how we got from 6 whole number 3 over 7, how we got 45. 7 times 6 plus 3 is 45. And 9 we cancel out with 45, you'll be left with 5 there. 7 we cancel out with 7, and that is how we got our result. 5 over 1 is the same thing as 5, which is equals to 5. 5 over 1 is the same thing as 5. Let's take another example. Multiply 1 whole number 2 over 11 by 1 whole number 7 over 26. The options are given. Solution. First, we change mixed numbers to improper fraction. Our given problem, which is 1 whole number 2 over 11 times 1 whole number 7 over 26, will be equals to 13 over 11 times 33 over 26. I hope you know how we got that. 11, the first fraction mixed number, turn it to a proper fraction, you have 11 times 1 plus 2, that is the 13 over 11, times, in the second mixed number, turning to improper fraction, will be 26 times 1 plus 7, that is 33 over the 26 there. And sometimes we cancel out, you'll be left with 3 over 2, and that is the same thing as 1 whole number 1 over 2. Another example. What is the value of minus 6 over 7, bracket open and close, times minus 7 over 18, bracket open and close, times minus 3 over 4, bracket open and close? The options are given. Solution. The brackets are written in this problem because of the minus sign. Hence, we will reduce to the lowest term even though the bracket is there. Our given problem will be equals to minus 1 over 1 times minus 1 over 3 times minus 3 over 4. What just happened here? 6 reduce 18 to 3 and 7 cancel out with the other 7. Now, our 3 can also cancel out. But let's first look at what happened with the minus sign. Recall that minus times minus is equals to plus. So the first two brackets multiply together, we will have plus, that's minus 1 over 3 times minus 3 over 4. And once that this is done, next, our 3 will cancel out from both brackets. Next, our result will be 3 will cancel out with the other 3, and plus times minus will become minus, and we have minus 1 over 4. Next, we'll be treating division, examples on division only. Simplify 3 over 4 divided by 1 over 2. Solution. Changing from division to multiplication, we invert the number that division is standing by in front of it. So we have our given problem 3 over 4 divided by 1 over 2 will be equals to 3 over 4 times 2 over 1. Next step is to reduce to its lowest term. Reduce to our lowest term. 2 we cancel out with 4 and we'll be left with our result will now be 3 over 2. And that is the same as one whole number 1 over 2. Another example. Simplify 1 whole number 4 over 5 divided by 2 over 3. Solution. First, we change the mixed number to improper problem. We are changing from mixed number to improper fraction. Our given problem will be equals to 9 over 5 divided by 2 over 3. Next, we change from division to multiplication. And that will give us equals to 9 over 5 times 3 over 2. No term we cancel out, so our result will be, we multiply out, and that will give us 27 over 10, which is equals to 2 whole number 7 over 10. Another example. Simplify minus 7 whole number 1 over 5 divided by bracket open minus 9 whole number 3 over 5 bracket close. The options are given. Solution. First, we change the mixed numbers to improper fractions. Our given problem will now be equals to minus 36 over 5 divided by bracket open minus 48 over 5. How did we get that? In the first mixed number, you use 5 to multiply 7, and that is plus 1. That's what gave you 36. In the second mixed number, 5 times 9 plus 3, that's what gave us 48. Next, we need division to multiplication by inverting the term after division sign. Next, we change division to multiplication by inverting the term after division sign. And that will give us minus 36 over 5 times minus 5 over 48. Sometimes we cancel out and recall that minus times minus is equals to plus. Our result will now be 6 over 1 times 1 over 8, which is the same as 6 over 8, which is equals to 3 over 4. Another example. Simplify 2 whole number at the numerator, 2 whole number 2 over 3 times 1 whole number 1 over 2, then divided by 4 whole number 4 over 5. The options are given. Solution. Change the mixed numbers to improper fractions. Also, recall that the bar sign symbol is a division, is division sign. That is to say, our given problem will be equals to 8 over 3 times 3 over 2 divided by 24 over 5. What just happened there? In the first case at the numerator, 2 whole number 2 over 3, you use 3 to multiply the 2 plus 2, and that gives you 8 over 3 in that case. In the second one, at the denominator, you have 4 whole number 4 over 5. That transforms 5 times 4 plus 4, 24 over 5. Changing division to multiplication, the result will be 8 over 3 times 3 over 2, then times 5 over 24 instead of 24 over 5. You have just changed from division to multiplication. Sometimes we cancel out and the result will be 1 over 1 times 1 over 2 times 5 over 3. And that will be equals to 5 over 6. Next, we take the subtopic cases in fraction involving addition, subtraction, multiplication, and division. Here, BODMAS is the rule to be followed, where B is for bracket first, then O is for off next, then D is for division, M is for multiplication, and A is for addition. Lastly, S is for subtraction. The example that follow will illustrate how these rules are applied. Let's take our first example. Simplify the big bracket open, then before you have another smaller bracket being open, 2 over 3 times 1 over 4, small bracket close, then minus 1 over 12, then before you close the bigger bracket. The options are given. Solution. We attend to the bracket first by the rule of BODMAS, and that will mean our given problem, we may choose to cancel out or multiply out. So in this case, we are multiplying out. So we have 2 over 12 minus 1 over 12. And taking the LCM of 12 and 12, you have 12 at the denominator. We are now left with fraction, with subtraction in the fraction. So we take the LCM of the denominator, which is 12. Then we now have 2 minus 12. And that will be equals to 1 over 2. Now, the result, what we have, since the two items given 2 over 12 minus 1 over 12, the LCM of the denominator 12 and 12 is 12. So in the first case, 12 going divide 12, you give you 1. 1 times 2 will give you 2. Minus, in the second case, 12 divide 12 is 1. 1 times 1 will give you 1. So we have 2 minus 1 over 12 there. And that will be equals to 1 over 12. Another example. Simplify. 4 over 5 of, bracket open, 1 over 2 plus 3 over 4, bracket close. The options are given. Solution. We treat the bracket first, following BODMAS rule. Recall that of is multiplication. That's our given problem, which is 4 over 5 of 1 over 2 plus 3 over 4, bracket open and close, this case, will be equals to 4 over 5 times, in the bracket, we take the LCM of 4 and 2, and that is 4. The first case, 2 divide 4 will give you 2. 2 times 1 will become 2 plus, at the numerator, 3. Because in that case, 4 divide 4 is 1 times 3 gives you 3. And that will be equals to 4 over 5 times 5 over 4. We've just done the addition, simple arithmetic in the bracket. 2 plus 3 is 5. Now we can now operate with multiplication. Sometimes we cancel out, and that will be equals to 1 over 1 times 1 over 1, which is equals to 1. Another example. Simplify 4 number 4 over 5 minus 2 over 5 divided by 4 over 7. The options are given. Solution. Applying BODMAS division first, our given problem will be equals to 24 over 5. We have changed mixed number there to improper fraction, minus 2 over 5 times 7 over 4. Division have been changed to multiplication. So hence, we inverted the 4 over 7 to 7 over 4. Next, sometimes we cancel out it in multiplication. Those two items multiplying each other. So we have our result will be equals to 24 over 5 minus 1 over 5 times 7 over 2 is 1. 2 divide 4 is 2. That is what happened there. And our result, since we have reduced to the lowest term, we can now multiply out those two terms. It will now be equals to 24 over 5 minus 7 over 10. Next, applying LCM of 5 and 10, that is 10, we now have, our given problem will be equals to, at the denominator we have 10 over 24 times 2 minus 7. Because the first case 5 we divide 10 and gives you 2. Hence we use that 2 to multiply 4. Minus the second case, 10 we divide 10 and that gives you 1 times 7 gives you the 7 there. So and that will be equals to 48 minus 7 over 10. The result is 41 over 10, which is equals to 4 number 1 over 10. Another example. Simplify 4 over 5 at the numerator minus 2 over 3. Then divided at the denominator, you have 1 over 3 plus 3 over 8. The options are given. Solution. We are expected to introduce bracket as our given problem will be equals to 4 bracket open 4 over 5 minus 2 over 3 bracket close divided by bracket open 1 over 3 plus 3 over 8 bracket close. Applying LCM to both brackets, we have to work on bracket first based on the rule of BODMAS. So we now apply LCM to both brackets, and that will become, in the first bracket, the LCM of 5 and 3 is 15. So you have 4 times 3 minus 2 times 5 at the numerator over 15. Then with our division sign, in the second bracket, the LCM of 3 and 8 is 24. So you will have, so at the numerator, 1 times 8 plus 3 times 3. How we got that in the first bracket is 5 divide 15, 3. 3 times 4, hence you have that result there. Then in the second fraction, 3 divide 15 is 5. So you have 5 times 2 there. Now in the next bracket, you have 3 divide 24, which is the LCM. 3 divide 24 is 8. 8 times the 1 that is there. Plus 8 divide 24 is 3. 3 times the 3 that is there. Hence, those results I'm saying, which is equal to, when we multiply out the numerators, we have in the first bracket 12 minus 10 over 15 divided by 8 plus 9 over 24. Our result will be 2 over 15 divided by 17 over 24. Changing from division to multiplication by inversion, that will now give us 2 over 15 times 24 over 17. 3 can divide 24 and then 15. So the result will be 2 over 5 times 8 over 17. And that will give us 16 over 85. Another example. Evaluate 1 over 4 of 36, bracket close, minus 2 whole number, opening a bracket, 1 over 3 minus 2 over 3, bracket close. The options are given. Solution. First, we change mixed number to improper fraction. Our given problem will become equals to 1 over 4 times 36, knowing that off is the same thing as multiplication, minus 7 over 3 minus 2 over 3, bracket open and close. Applying broad mass, it's a bracket first, and that will give us 9 minus, the first bracket will reduce to 9, then we cancel out there. Then in the other bracket, at the denominator will be 3, numerator will be 7 minus 2. Simple arithmetic operation that took place there. LCM of 3 and 3 is 3. 3 divided 3 is 1. 1 times 7 remains 7. Then in the second case, 3 divided 3 is 1. 1 times 2 remains 2. And the result will be equals to 9 minus 5 over 3. And that will give us 27 minus 5 over 3. We just use 3 to multiply 9, then minus 5 over 3, which is equals to 22 over 3. And that is 7 whole number 1 over 3. We've come to the end of the examples under this subheading. Next, we have some exercises. I would advise you try your hands on the exercises taken at page 33, 34, 35, 36 of the hidden fact in JSCE mathematics. The answers are provided at the answer section of the book, of either the hard copy or the soft copy. Thank you.